Good morning, students. Let us next see the isosceles triangle theorem. The statement of the theorem is, if two sides of a triangle are congruent, then the angles opposite to them are congruent. So in triangle ABC, side AB is congruent to side AC. Now we have to prove that angle ABC is congruent to angle ACB. Now the construction is, draw the bisector of angle BAC which intersects side BC at point D. So in triangle ABD and triangle ACD, segment AB is congruent to segment AC. Angle BAD is congruent to angle CAD by construction, and segment AD is congruent to segment AD by common side. So therefore, triangle ABD is congruent to triangle ACD by SAS test. Now angle ABD is congruent to angle ACD, corresponding angles of the congruent triangles. Therefore, angle ABC is congruent to angle ACB. Now statement of the next is here corollary. Now corollary is what here? The property which we derive by considering the statement by using the result of the theorem is called as the corollary. Now if all sides of the triangle are congruent, then its all angles are congruent. Now you have to write down the proof of this corollary, but you just remember the statement of the corollary. There is no need to write down the proof or learn the proof. Now next is here the converse of the isosceles triangle theorem. Now if two angles of a triangle are congruent, then the sides opposite to them are congruent. Now in converse, you know, whatever is given in the theorem becomes the to prove and vice versa. So now here it is given that in triangle PQR, the two angles are congruent. Angle PQR is congruent to angle PRQ. And now you have to prove that side PQ is congruent to side PR. Now again here the construction is, draw the bisector of angle P intersecting side QR at point M. So in triangle PQM and in triangle PRM, angle PQM is congruent to angle PRM. This is given. Angle QPM is congruent to angle RPM. This is by construction. So you have to write segment PM is congruent to segment PM common side. So therefore triangle PQM is congruent to triangle PRM by SAA test. So therefore segment PQ is congruent to segment PR. Now next here we will see the property of 30, 60, 90 triangle. Now property of the 30, 60, 90 triangle is here, if the acute angles of the triangle have the measures 30 and 60, then the length of the side opposite to 30-degree angle is half the length of the hypotenuse. Now here this you have to prove this one in triangle ABC. Angle B is equal to 90, angle C is equal to 30 degree and angle A is equal to 60 degree. So you have to prove that AB is equal to half of AC. Now construction here, take a point D on the extended AB such that AB is equal to BD. Now draw TC. Now in triangle ABC and triangle DBC, see here in the figure, AB is congruent to BD, this is given. Angle ABC is congruent to angle DBC 90 degree. Segment BC is congruent to segment BC common side. Therefore, triangle ABC is congruent to triangle DBC by hypotenuse side test. So angle BAC is congruent to angle BDC, corresponding angles of the congruent triangle. Now BAC is 60 degree, so BDC will also be equal to 60 degree. Now angle DAC and angle ADC, angle ACD all are 60 degree. Sum of the measures of all the angles of the triangle is 180 degrees. Therefore triangle ADC is equilateral. So AC is equal to AD is equal to DC. But AB is equal to half of AD. So therefore AB will be equal to half of AC. So this way we can prove. Now next we have to see that here, if the acute angles of the right angle triangles are of the measure 30 degree and 60 degree, then the length of the side opposite to 60 degree angle is √3 by 2 times hypotenuse. So in the above theorem we have proved AB is equal to half of AC. So you have to prove that here AB square plus BC square is equal to AC square. Now AB is equal to half of AC. So substitute that value. So that becomes half 1 by 4 AC square plus BC square is equal to AC square. So therefore BC square is equal to AC square minus 1 by 4 AC square. So BC square is equal to 3 by 4 AC square. So BC is equal to root 3 by 2 into AC. Now next theorem is here, this one. If the measures of the angles of the triangle are 45, 45, 90, then the length of each side containing the right angle is 1 by root 2 times hypotenuse. So in triangle ABC, angle B is equal to 90 degree, angle A and angle C are 45 degree each. So BC is equal to AB. So by Pythagoras theorem, AB square plus BC square is equal to AC square. So AB square plus AB square is equal to AC square. So therefore 2AB square is equal to AC square. So AB square is equal to AC square upon 2. So AB will be equal to 1 upon root 2 times AC. So this property is called as the 45-45-90 theorem. So now this you have to remember that if the acute angles of the triangle, right angle triangle are 30, 60 and 60, then the length of the side opposite to 30 degree angle is half of the hypotenuse and length of the side opposite to 60 degree angle is root 3 by 2 times hypotenuse. This property is called as 30, 60, 90 theorem. Now second one, if the acute angles of the right angle triangle are 45 and 45, then the length of each side containing the right angle is 1 by root 2 times the hypotenuse, that is the 45, 45, 90 theorem. Now let us next see what do you mean by the median of the triangle. The segment joining a vertex and the midpoint of the side opposite to it is called as the median. So in figure 3.32, point D is the median of the side BC. So segment AD is the median of triangle ABC. So here we see that this point of concurrence of the medians of the triangle divides each median in the ratio 2:1. So here in the figure in triangle ABC, segment AD, BE and CF are the medians of the triangle. All of them intersect at the point G. G is the point of concurrence of the median. So this point G, it divides the medians in the ratio 2:1. So here you will get BG. So here next we will see the property of the median drawn on the hypotenuse of the right angle triangle. Now the length of the median here, see here in the figure in triangle ABC. BD is the median drawn on AC. So this BD is equal to half of AC, means length of the median drawn on the hypotenuse is half of the hypotenuse. So BD is equal to AD is equal to BC. So here this we will prove by using this theorem here. In a right angle triangle, the length of the median of the hypotenuse is half the length of the hypotenuse. So in triangle ABC, angle B equal to 90 degree, segment BD is the median. So BD is equal to half of AC you have to prove. So construction, take a point E on ray BD such that D lies between B and E. So length BD equal to length DE. Draw segment EC. Now in triangle ADB and triangle EDC are congruent by SAS test. Line AB is parallel to line EC. So therefore triangle ABC is congruent to triangle BCE by SAS test. So BD is equal to half of BD is equal to half of BE. So BD is equal to half of AC. Practice at 3.4. given point A is on the, now practice set 3.3. Find the values of the x and y from the figure using information. Now find measure of angle ABD. Now solution in triangle ABC, segment AB is congruent to segment AC. So measure of angle ABC is congruent to angle ACB, isosceles triangle theorem. So therefore x is equal to 50 degree. Similarly in triangle BDC, BD is congruent to DC. Therefore angle DBC is congruent to angle DCB, isosceles triangle theorem. So therefore y is equal to 60 degree. Now measure of angle ABD is equal to measure of angle ABC plus measure of angle DBC. So 50 plus 60, that is equal to 110 degree. So ACD will be equal to ACB plus DCB. So 50 plus 60, that is 110. Now the second sum, in triangle ABC, angle B equal to 90 degree. Segment BM is the median. Segment AC is the hypotenuse. AC equal to 15 degree. To find BM. Now BM is equal to half of AC. The length of the median on a hypotenuse is half the length of the hypotenuse in a right angle triangle. So BM is equal to half of 15 degree, that is 7.5. Now in third one, in triangle PQR, angle Q equal to 90 degree, QR equal to 5. Segment QS is the median. You have to find out QS. Now in triangle PQR, PQ square plus QR square is equal to PR square. So 12 square plus 5 square, that is 144 plus 25, that is 169. So PR is equal to square root of 169, that is 13. So QS is equal to half of PR. So length of the median is half of the length of the hypotenuse. So half of 13 equal to 6.5. Now fourth one, in triangle, point G is the point of concurrence of the medians. GT equal to 2.5 to find out PG and PT. Now GT is equal to 1/3 of PT. Centroid of the triangle divides the median in the ratio 2:1. So 2.5 is equal to 1/3 into PT. So PT will be equal to 2.5 into 3. So this is PT is equal to 7.5. So PG is equal to 2/3 of PT. So 2/3 into 7.5. So that is equal to 5. So PG is equal to 5.